Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends and even your younger brothers and sisters who would want to take up engineering courses in the future. So this video is important for you to prepare for engineering life in the future. And I hope that my videos are important and can help in your preparations for you to become better students in engineering and hopefully successful engineers. In this video, I will derive the formula for the volume of a cylindrical wedge and also the formula for the location of its centroid using my knowledge in integral calculus. And I hope that you are already at this level who can understand the solution to this problem. So this is the cylindrical wedge and this is the diameter of this circular section. So we will denote the elements of this wedge and let's superimpose the axis. So let us say this is the x-axis, this is the y-axis, and this is the z-axis. And the radius of the circular section, the base is r. And we draw this line along the slanted plane and the height is r, the angle here is alpha, and so that in this right triangle the midsection tangent of alpha is h over this distance, which is the radius also of the circle. Then tangent alpha is h over r, that means h is r tangent of alpha. Likewise, the equation of the circle, if you can recall from algebra or from analytic geometry, the equation of the circle is it is on the xz plane, therefore it is x squared plus z squared equals radius squared. So that's the equation of the circle. And you can also establish that by considering a right triangle here and apply Pythagoras theorem. So let us say that is x, that is z. So I will explain it by considering a slab as shown. So this is our elemental slab with dimensions z. This is z and this is z also. So that is z and the height is along y, so that's y. And the thickness of this slab is dx. The distance of the slab, by the way, from or along the x-axis, because it is a vertical plane parallel to the yz plane, is x as shown, and the thickness of the slab is dx. Of course, the centroid is here, so that's why the distance of the centroid of the slab from the yz plane is simply x, while its distance, the distance of the centroid of this elemental slab from the xz plane is of course half of the height of the slab, so half of y. So differential volume is the volume of the slab, and the volume of the slab would be the area of this rectangular slab with length 2z, z plus z is 2z, and the height y, so 2z times y times the thickness dx. In short, area of the rectangle times thickness dx. So take note that this is x, this is z, and from this point to this end is radius. That's why by Pythagoras theorem, if you look at from the top, we have x squared plus z squared equals hypotenuse squared, which is r squared for beginners, for the new ones, as long as you have integral calculus. So from the figure, from this equation, z is square root of r squared minus x squared. That's the value of z. While in this triangle, by similar triangles, take note that the height of the slab is y and this distance is x. So we have similar triangles here. Y as to x, this is dx, equals h as to r. by similar triangle, y as to x equals h as to r. So that means y is h over r times x. So substitute here, differential volume is 2, z is square root of r squared minus x squared, y is h over r times x, then copy differential x. Simplifying, volume equals 2h over r. Let's make it negative h over r, then quantity r squared minus x squared to the 1/2, this radical here, then negative 2x dx. So this is the same as that. We have positive 2h over r, negative, negative, so that is positive 2h over r. The purpose of rearranging or transforming the integrand in this manner so that we can evaluate the integral by power formula. So take note that if we let u be r squared minus x squared, this one, the differential of r squared minus x squared is, because r is constant, so it's just negative 2x times differential x, which is this. Therefore, this integrand is in the form u to the 1/2, and this is differential of u. So u to the 1/2 differential of u. So volume therefore is negative h over r. The integral of u to the 1/2 du is u to the 3/2 over 3/2, or simply, so negative h over r, 2/3 of u, quantity r squared minus x squared to the 3/2 from 0 to r. So the limits, by the way, is from 0 to r because the variable of this integral is x, defined by or described by the differential in x. So that's why it is from 0 to r. Then if we substitute the upper limit, we have r squared minus r squared, so 0. Then lower limit, r squared minus 0 squared, quantity to the 3/2. So minus quantity r squared minus 0 squared to the negative 3/2. So that's negative r cubed. So negative r cubed times negative 2/3 of h over r, that would be positive 2r squared, 2/3 r squared h. So volume is negative 2h over 3r, quantity 0 minus r squared minus 0 squared to the 3/2. So simplifying, volume is 2/3 of r squared h. So because h is r tangent alpha, the volume in general for this cylindrical wedge is 2/3 r squared h, or 2/3 r cubed tangent of alpha. There is a shorter and direct way of deriving this because the prismoidal formula can be applied. So this is section 1, that's section 2, and this is section M, the midsection, which is a right triangle with dimension base, radius, and height h. Section 1 is a point section, so the area is 0. Section 2 is also a pointed section, so the area is also 0. The volume by prismoidal formula, if you can recall, is L over 6, quantity area 1 plus 4 times the area of the midsection plus area 2. So again, area 1 and area 2 zeros, and L is the distance between sections 1 and 2. In this case, the distance between sections 1 and 2 is simply the diameter of this circular base, or 2r. So substituting, while area M, area of midsection, is 1/2 area of this right triangle, which is 1/2 r times h. So volume equals 2r over 6, quantity 0 plus 4 times 1/2 of r times h plus 0. So 4 times 1/2 rh is 2rh times 2r over 6, that's 4 over 6 r squared h, or 2/3 r squared h, which is the same as that. So volume is verified as 2/3 r squared h, or 2/3 r cubed tangent of alpha. We now proceed to the derivation of the location of its centroid from integral calculus, which is interpreted as Varignon's theorem. Volume times xg is equal to integral of the x coordinate of the centroid of the element times differential volume. So volume times xg equals integral of x coordinate of the centroid of the element, which is in this case the slab, times dv. This x of element is simply the distance of the centroid of this slab. When projected, it's here, and the distance from the YZ plane is simply x. So x sub e is just x, and differential volume is equal to this part. So we just copy that. So volume, which is 2/3 r square h times xg, equals integral from 0 to r of xe, which is just x, then differential volume 2 square root of r square minus x square h over r times x dx. So simplifying, we cancel out 2, then we also cancel h, then we'll have xg equals 3 over r cube, because we have r here. So xg equals 3 over r cube, integral from 0 to r of x squared square root of r squared minus x squared dx. So x times x is x squared, and copy this, square root of r squared minus x squared. From our experience in integral calculus, when the integrand involves constant square minus variable square, we put the variable equal to constant sine of theta. So x is r constant sine of theta. Then the differential of x is r cosine theta d theta. I will not draw a right triangle anymore, defining x equals r sine theta, or sine theta is x over r, because this r square minus x square is simply r cosine theta, because when we substitute the value of x, which is r sine theta, this is r square sine square theta. Then this radical becomes r square times quantity 1 minus sine square theta, or simply r square cosine square theta. Square root of r square cosine square theta is r cosine theta. So this is r cosine theta. And when we change limits, when x is 0, so 0 over r is 0, arc sine of 0 is 0. So the lower limit is still 0. When x is r, the upper limit, r over r is 1, and inverse sine of 1 is pi over 2. Or with your experience, supposedly I will not explain that. But for those who are first timers and for those who are reviewing, you might forget the condition here in changing the limits. So the limits would now be 0 to pi over 2. So xg equals 3 over r cube, integral from 0 to pi over 2. Then this is r sine theta quantity square, r cosine theta, then r cosine theta d theta. So we have r to the fourth here divided by r cube. So this becomes 3r. So xg equals 3r, then integral 0 to pi over 2 of sine square theta cosine square theta d theta. So again, from integral calculus, we have these definite integrals with limit 0 to pi over 2. We can apply the Wallay formula or Wallis formula. I just read that as Wallay formula, because the meaning of Wallay in Filipino is no formula, no, nothing. So Wallay formula, the rule is we have for sine minus 1, so it's 1, we stop at 1. Remember, the power is reduced by 1, then by 2, and so on and so forth until it reduces to 1 or 2, when then we stop at 1 or 2. But this is already 2 minus 1, so it's 1. For cosine, this is 2 minus 1, so we stop also at 1. So 1 times 1, then times the angle alpha. In this case, alpha is pi over 2 because both 2 and 2 are even. That's the condition. If not otherwise, then alpha is just 1. Then the denominator is the sum of the powers decreased by 2 until the value becomes 1 or 2. We stop at 1 or 2. So originally in the denominator it is 4, then reduced by 2, so times 2, we stop at 2. So therefore, the integral here is 1 times pi over 2 over 4 times 2. So xg is 3r, quantity 1 times 1 times pi over 2 all over 4 times 2. So in other words, the integral here is equal to pi over 16. Now, if you're allowed to use the high-tech calculator allowed in the allowed by the professional regulations and commission can evaluate definite integral. So you can also evaluate this by your calculator, and it should be pi over 16. But if you want to be or if you want to excel in mathematics, and if you want to easily recall formulas by deriving them, then I will suggest that you should follow this solution, not by evaluating the integral by using your calculator most of the time. So you have to evaluate so that you can also review integral calculus. So this is 3 pi over 16r. So xt is 3 pi over 16r. So that's it, and you don't need to memorize. As long as you know the principle of integral calculus, then you can easily derive that formula. So likewise, we have to evaluate yg, the location of the centroid of this cylindrical wedge above the xg plane. So that's yg. So by first moment of mass principle in integral calculus or Varignon's theorem, volume times yg equals integral of y of the element centroidal y of the element times differential volume. So if, as I said in the figure, the y of the element, the centroid of the slab is, of course, because this is rectangular, half of the height. If the height is y, then it is y over 2. So volume 2/3 r square h yg equals integral from 0 to r of y over 2. Then we copy differential volume, which is 2 square root of r square minus x square h over rx dx. So we cancel 2, then we replace y by h over r times x. So 2/3 r square h yg equals integral from 0 to r of h over rx, then square root of r square minus x square, then quantity h over r times x dx. So simplifying, take note that we can cancel h, then the denominator would become, so the numerator becomes 3h, so we have yg equals 3h over 2 r to the fourth, then integral of x square, square root of r square minus x square dx. So yg is 3h over 2 r to the fourth, integral from 0 to r of x square, then square root of r square minus x square dx. So take note that this integral is the same as this integral here. So therefore, this integral will give us, by our experience here, will give us a value of pi over 16. So that's pi over 16 because 3r is a constant before the integral sign. So integral from 0 to r of x squared square root of r squared minus x squared dx. By our experience from the preceding solution, it is pi over 16. So yg equals 3h over 2r to the fourth, then r to the fourth integral, by the way, r to the fourth from here, integral of sine squared theta cosine squared theta d theta. So we can cancel r to the fourth, and again, by our experience, this is pi over 16. So yg equals 3h over 2, quantity pi over 16. Therefore, yg is 3 pi over 32h. Because h is r tangent theta, it is also 3 pi r 3 pi r tangent alpha over 32. Sorry, h is r tangent alpha. So yg is equal to 3 pi over 32 times h, or 3 pi r tangent alpha over 32. From the figure, the x-axis is an axis of symmetry. Therefore, the location of the centroid, or the value of z sub g is 0. So g sub g is 0 from the figure, because this cylindrical wedge is symmetric with respect to the yz plane, or the yz plane divides the solid cylindrical wedge into two equal parts. So that's it, and I hope that you were able to follow the explanations and the solutions. As a graduate of engineering, you should be able to follow and understand the solutions. And, but if you cannot follow, it means that you're not prepared as an engineering student, or something is wrong with your preparations if you cannot follow the solutions, because these were the solution and steps in integral calculus. So I just hope that you are able to follow. But you can ask questions if you want in the stream or in the comment section.